Howdy folks, welcome back to another video. We're finally going to do some machining on the Moto-Resto machine and repair channel. Yeah, go figure. We're going to go ahead and make this mandrel or arbor, whatever you want to call it. And what the purpose of this is, I want to put the pulley, the main drive pulley for the spindle on the mill, which is the 4-step big pulley, over in the lathe and clean up the V-belt grooves faces because they're running out. They're all cattywampus. Perhaps from wear, maybe they weren't made right in the first place, I don't know. I did the other three, the main motor drive pulley and the two idler pulleys off camera a while back. It definitely helped, so I wanted to do this big pulley. The only way to practically do that is to match the taper, because that's a tapered pulley on a tapered spindle, and we have to make a taper on this. We had to make the thread to match the nut that holds that pulley in place normally. I think I found a crafty way to measure that taper on the mill in situ and verify it on the pulley itself. Now I'm going to tell you right now that there's a lot of setup clips in this video. If you don't like that kind of stuff, I apologize. You can either fast forward, go watch something else, I don't know. I'm cutting it down to the bare minimum, but I thought it would be interesting content to show you how I solved that problem as far as measuring a taper per inch without taking that spindle out, putting it in the lathe, which you traditionally do, and then go ahead and match that taper with the compound. So if you watch this video, you'll see exactly how I did that. So I hope you enjoy it. We'll see you at the other side. Welcome back to another video. In this video, we're going to go ahead and machine a special arbor, a tapered arbor, to hold this pulley, because what I want to do is I want to remachine the angle between each of the V-belt parts of the pulley, 1, 2, 3, 4, and these 4 steps, because this thing's not running exactly true. I'll show you what I mean. It's kind of hard to explain because when I put an indicator on each one of these, it actually shows it is true, but there is some sort of a problem in it, and it's causing the belts to wobble, especially on this side. And anyway, let me show you what it's doing, and I'll explain what I've done so far, and that'll give you an idea what we need to do now. All right, so I'm going to turn on the VFD. Now you can see this main pulley belt bounces around pretty good, causes somewhat of a vibration on the machine. You can hear it, it's kind of squeaking. And I think that's because the belt is not being captured properly. You can see the back one off the main motor pulley. The first idler and the second idler, they're all running pretty good on the belts that go between them. I mean, that's dead nut straight. That one's pretty much dead nut straight. This one here goes between the second idler and then the main spindle pulley. It's got quite a bit of variance. And for the life of me, I really can't figure out why, except for the pulley itself needs to be just cleaned up. I'll show you what's going on with this real quick. Just put an indicator up here and you can get an idea what I'm talking about. This is just on one, the V-belt grooves. And you know, that's pretty damn close, a couple thou. And it's not like the spindle is bent or moving. I mean, you can always force it to do that, but you know, make it move a little bit. The bearings in the spindle are fine. I replaced those, they're nice and snug. This thing's not moving around. I honestly can't really figure out why it's doing this, because when I do this, it just looks pretty good. But you can see it's wobbling around. I think it has to do with essentially the flats on the V-belt grooves. I don't think they're parallel to one another. Could have been machine cattywampus, and these things could be true to the spindle as far as that taper and way it sits, but they may not be exactly true to each other. I don't know. I mean, it's possible for that to be the case. Just got to skim it anyway like we've done. It worked on the other 3 pulleys, so I have no reason to believe it wouldn't work on this one. It's just more challenging to do because of the fact that we got a taper inside there. But even if we move this down to the bottom here, yeah, so the bottom one, as you can see, is much further off. And it's bouncing all over the place. You know, besides the oscillations of the needle because of the irregularities in the surface finish. So basically what we need to do is we need to clean this up, like I said with the other ones. I'll give you a close-up shot of this second idler here. You can see an idea what it looks like when you get it done, and she's just beautiful. By the way, I put new bearings in these too. I forgot to mention that before. These have brand new bearings, really good bearings. They're FAGs. They're very smooth. The old bearings felt good, but when you took them out and took a look at them, they were pretty trash. 1977 bearings with that grease that stinks like the 70s. So these came out really good. We just want to make this one look the same. And I think we're going to solve these vibration problems because at higher RPM, it does get to be a little annoying. I should probably mention that this is not a byproduct of the installation of the three-phase motor. This vibration and so forth you can see here. It was actually much, much worse. These are new belts too, by the way. I put 3 brand new belts on. Anyway, what happened was I noticed this on many months ago when I would change the belt positions to make this thing run faster with the old 240 motor on it. As soon as you got up to those particular speeds, like whatever it's rated up here, you know, for the higher pulley positions as far as the ratio goes, this thing would vibrate. And I could always see that it was in the belts and the way the belts were moving. These back ones were worse than the one you just saw here. This one in particular off the motor was really vibratory, and so was the second one between the two idlers. And so that's what gave me the idea to take these off and remachine them. Now, by remachine, what I mean was all I did was pick up this angle, which I think is a 36-degree included angle, and in the lathe, and you made an arbor for these. These two take the same arbor. I'll show you that here in a second. I made a special one for this. I didn't film any of this stuff because I was experimenting. And then I picked up the main bore because that reducer sits in the main bore, and that's referenced off that anyway. Put it in the lathe, picked up the angles with a dial indicator, and then just skimmed them. Just touched them to clean them up. Cleaned up the bottom. So this does 2 things. It cleans up and evens out the spot where the belt goes inside the pulley, and it also helps to balance it because I'm cleaning up any irregularities. Same thing on the 2 idlers. Everything came out good. That really straightened this part out. I mean, these things are running dead true, but this one here is doing this. It's got to be this pulley. We need to do the same thing on this one that we did on those. Now this one I used, I'll show you the arbor I made for it. To get an idea what I had to do is I just made an arbor like this. It's a 2-piece, but it's pressed on, has a 1/2 inch 13 bolt in the end to hold it on, a couple washers. And again, that took care of the idlers in the center because they're just bigger. You know, the board, there's bearings in there. So once I figured out what the size was, I just banged this out of some 1045. That's actually a piece of cast iron or ductile iron from an old pulley that I butchered up for something else, then re-butchered it. But it worked out really well. Got a set screw in there, and Bob's your uncle. That definitely worked. So we're going to do pretty much similar to this. This is the material we're going to use. It's some sort of mystery metal that used to be a square bar for a homemade kind of trailer hitch that somebody made. Cut it off in the bandsaw, scrapped the rest of it. We just kept this because I figured I could use it for something, and that's exactly what I'm doing right now. The hole for the pin, it's not going to be a problem. This will be the end we're going to chuck into the machine, and we'll put the taper and the thread at this end because it's got jaw marks there because I cut the majority of it this way first, then spun it around, clamped it in the machine, the 3-jaw. I used a 4-jaw to just, you know, chuck up the square bar at that point, which obviously is pretty much the only way you can do it. Dialed it in just kind of quick and then just started whittling away at it. I don't really like doing that kind of interrupted cuts, kind of bangs up the lathe a little bit. Had one little faux pas. The quick change tool post loosened up and it actually started to drag the tool in. And so I corrected that and just kept going, you know, recut it. And surface finish is okay. It's a little bit of draggy here and there, but it'll work out for what we got to work out to. 1.950 right now, so just under 2 inches. So anyway, that's what we're going to use. I got centers at both ends, and so we'll move on from here. I just wanted to show you the material. Let's go on and to the point where we got to pull this pulley off, and I'll show you the challenges we have in regards to the taper. I'm guessing you know the drill on this one. You saw in the other mill videos, so we'll just buzz through this. All right. There it goes. All right, nothing to it. Okay, threads, taper. I'm going to talk about taper here in a moment. What I need to do now is figure out a way to how we're going to measure this taper. And that's when we'll talk about the taper itself, because I got a couple of ideas. The main thing I want to look at is the threads, because I need to cut these threads on the arbor we're going to make. And I'm not sure, I haven't measured these yet, whether these are imperial or metric. A lot of the stuff on this old mill from the 70s from Taiwan is imperial. I'm hoping that the spindle it'll be much easier for me to cut these threads. If I can stay in imperial, I got to change gears and change my methodology if I'm cutting a metric thread, but it's not impossible. So let's set up and do that real quick and see what it is. Let's see what we got. I bet you that is metric because it's coming in at 1.647. That doesn't sound like anything imperial. Let me get the thread pitch gauge out and see what it matches up with. As far as any fractional thread size on this, I got no idea. I can only go off the decimal side. 41/64 I think is the closest to this, but it is most definitely a 16 TPI thread pitch. The closest to 16 is a 1.5 in metric basically, and that don't fit, but 16 fits perfectly. So it's some unusual diameter that they decided to make this out of and then make the nut, which is fine, you can do that. But this is not a standard imperial size. Like I said, 6/47, which is like, I think it's something like 41/64 or something like that, close to it at least. We're gonna make this 16 TPI and just duplicate whatever the size is here, but it's kind of weird. Okay, so we need to know what this taper is to dial in on the compound lathe to duplicate it. We're simply using it as a comparator really, because we don't know what the taper is as far as the degrees go. Now, if you knew that, or you could look it up in like Machinery's Handbook, you can use a sine bar, dial your compound in, so when your compound moves, it'll be 0, 0 on this angle, and then you're done pretty much. Then you can cut your workpiece. And if you look on Matty's workshop channel down under in Australia, he uses a nice little sine bar setup quite often. I'll put a link to his channel in the description. And so that's a real common way of doing it if you know the taper, like a Morse taper or something. But I don't know what this taper is, so we would be utilizing the existing taper as a comparator to set the compound angle. So the way to do that would be obviously to take this out, put it in a lathe, and just run it back and forth on the compound until you get this angle 0, 0 on your indicator. You got to indicate it in. But that's too much work. I'm not going to do that because I don't want to take all this thing apart. So there's two other ways we can do it. We can pick it up right from the bore itself because the taper's in this way. So we put it in a lathe. So this is facing away from the chuck then. In other words, this is toward the tool side. And we run an indicator right, maybe just a little bit in, and then spin the workpiece until that indicator, make sure the indicator is true. And then as long as we don't move the Z during that test, we do move the Z and then move it in toward the back, do the same thing. That way we can get this thing so it's not cattywampus this way, because we don't have a lot of good reference features off of this. We might do that, but there's one other way too that I think we're going to try, because we got a DRO and we got a 3-axis DRO, so we have Z DRO control as far as how much this moves down. For example, like that. See how the drawbar is moving down relative to the spindle. So why couldn't we do a taper per inch measurement? Set up an indicator on the drawbar, which is locked in, by the way, right now with just a collet and a piece of stock. So this is essentially connected to this. I'll clamp the indicator up here. Try to find the high spot, because it's very important you find the actual high spot, the center of this taper, otherwise your taper won't be accurate. We can run it down exactly 1 inch on the DRO and see what that measurement is. And then what we can also do is go over to the lathe, like I said, put that pulley in and measure the same thing and see how it compares. But if we do it this way, we have to translate that to exactly 1 inch when we're setting the compound up essentially on a straight piece. So we have to extrapolate that taper per inch over to a straight piece, and that will result in the appropriate taper. And it's kind of hard to explain. I'd have to actually show you. We don't have a DRO except on the Z-axis, which is the carriage in and out, and the X-axis, which is in and out. We don't have one on the compound. Or do we? Well, we are if you're a student of the Moto-Resto School of Overcomplication, because I took the old mill quill DRO off and just kind of quickly banged this thing in, and banged it up rather, so we can actually have finite measurement on the compound when she moves in and out. So I kind of wanted to try this, you know, because sometimes I do need that kind of control, but very rarely. This would be something like if you're moving it in for some sort of an internal groove or an angle or something like that. This would work to do that. So we could take 1 inch over there, up and down on that, and translate it to 1 inch over here, put the piece of stock in, and then just run this in 1 inch until that matches that exact number that we got over there. All right, so I got a stair at 196 clamp to the drawbar, which, as I said before, the drawbar is tight to everything, so it's not going to spin independently or move. What we're going to do is just kind of swing it back and forth. I don't have this completely tight yet as far as this clamp up here, and try to find the high spot, but we got to make sure that the indicator is as perpendicular to this front surface as possible. And it looks pretty good right there. And as far as picking up the high spot, I'm just going to rotate it back and forth with a little tension on this thing. And all I'm going to do is I'm just going to bring this like this till I get a high spot. I'm reasonably confident now that we're in the center of this bar and this is at the right angle and relationship to it. In other words, this way. All we got to do now is just set the 0 on the DRO. We're just going to go down 1 inch. Once we zero this out, of course. We need this exactly on 0, the DRO on 0. Yeah, see, something was wrong. 38. I thought it was going to go less. So 38 thou. I just reset everything. I'm going to do a couple more off camera and see if I can get some repeatability here, because for some reason when I'm coming back to 0, I'm not coming back to 0, and I'm not sure why. All right, doy. Somebody's a complete idiot. What's happening is my stupid clamp up here is sitting on the top of the threads. You probably saw that. And it's moving it. Idiot. Let me reset this. What a moron. I have no idea how I didn't see that. I'm a dummy. In order for this thing to fit, we have got to be dead nuts right on the top edge of that taper because of the body shape of the indicator for it to clear down here. One inch. Yeah, that's a little different. 53 thou, right on the money. So let's see if we can repeat it. We should be able to go back up to 0 and have it read 0. Yeah, that's a lot better. And we're back dead nuts on 0 here. I'm going to do it a few more times off camera and then we'll come up with a final number. Okay, I did it a couple more times. I'm coming up with the same number. My eyes are just not that good at this angle with these glasses. Got 3 repeated events of measurement, so we'll write that down. What we can also do is just really quick, I'll just put the outside jaws in on the chuck. We'll throw that pulley in there, and then we'll run down that and see what that is. Okay, we're all set on concentricity. From the outside to the inside, using this setup, this is the same setup we're going to do to measure our 1 inch in. As far as the indicator height goes here, I went ahead and I set that to the live center. So I know that that's in the center of essentially the center of the bore of the, as far as the spindle goes, this is all lined up and that's on center line to the spindle. I have to have it angled back a little bit this way because the bore opens up on the inside, otherwise it hits this bar we're on 0 there. Go ahead and 0 the DRO on the Z-axis. I'm going to be very careful because it's really easy to crash this, and I can't move that away anymore because it's lined up to the other end of that tip. Okay, so let's just go nice and easy. See if we can actually make this happen without crashing. Remember, this indicator is going backwards because the bore gets bigger or larger from the outside to the inside. The indicator has to move to the negative to compensate. So I've loaded it up past what I expect it to be at 53 thou. I gotta get my damn magnifying glass. I just can't see that. 52 and about 8/10. So what did we say, 53 before? That is almost exactly the same, which is pretty amazing. Let's go back up to 1 inch. One inch exactly. We are like 50, 52 and 9/10. We're at 53. That's what we got on the other machine. Let me show you up close here what it is. We got 53 thou on the other machine doing it exactly this way. So let me see if I can get you at that level. And remember, it goes the other way around. It's not reading in the positive, it's reading in the negative, so it's going this way. So 53 thou. We're going to do 53 thou as our taper per inch. And it's really kind of cool. I'm glad I did this. I was always wondering this, you know, when I was setting up in my mind to do this project. If I measured that taper, can I get it accurate enough where it'll match the taper per inch here? And we did. And I think that's pretty cool. So now we can all just go home. Now we can get the material set up and we can actually indicate the compound end, and then we can make some cuts and stuff. Okay, so I know it's a dangerous thing, but I was actually thinking. I was thinking, why couldn't I just utilize the same setup, run the indicator in and out of that taper, angling the compound to match until that reads 0, 0 and see what we got. So this is exactly what I did. Picked up a 0 and I'm just running it in and out. And I got her pretty much dead nuts. And where we're at is 3 degrees. According to this. Now I don't trust that as far as I could throw this lathe. Maybe just a skosh more than 3. And so now we can verify this by taking all this setup down and then just putting the part in. Okay, I put the indicator back here and back and up front here closer to the chuck. This was actually out 5 thou. I'm not entirely sure why. I was in a 4-jaw and a different setup, and sometimes these things vary. So to compensate from that, I just calculated what was the low side when it was turned that way and put a 5 thou shim over here, and that's dead nuts. Out here, I can't get any closer than 2. I recut the center best I could. Unfortunately, without tailstock, not tailstock, but like a steady rest support, it's going to be very difficult to do. So I got it as close as I can get it. Maybe I'm being a little too anal. I mean, when do I ever do that? This indicator is back in line with the center line of the spindle, you know, based upon the live center, the tip of the live center, so we're good there. So what we're going to do now is, this doesn't matter. This angle here doesn't matter. This is more of a convenience thing. I'm just going to rotate this in to get a little bit more square. Once we do that, lock it all down. We'll load up the indicator like 70 thou or so. Now this is when we'll turn on, or turn to rather, little quill indicator, digital readout I should say, that I just put on a little while ago for this purpose. And then we'll zero that out, crank it over 1 inch, and then see, hopefully I have this back far enough where it'll actually do 1 inch. Oh, I see what happened. One for crap. I have this little edge hanging out too much and it's catching on this stupid thing. Hang on. You can tell it's a Monday, I tell you what. I got that taken care of. This is a temporary setup. I just did this for right now and I can always reuse it if I need it again. We're re-zeroed. I got plenty of room. I backed off the compound, so now we definitely have 1 inch worth. Let's try it. Maybe we can actually get it to read this time without it hitting something. 1 inch. That's reading 54 thousandths now. I'll have to redo that because I'm not really sure. Maybe 53 and a half. Everything's driving pretty good, I think, which is kind of cool. Because like I said, I never did this before. And I'm just trying to play with it and see what we got. 53.5. So I'm going to go ahead and readjust this off camera and get it to read 53. Okay, 1 inch. It's actually 52 and about 8/10, but close enough. You get to a point where you're splitting hairs. So I'm going to call that good. I got everything tightened back down. Now we're not going to use this immediately because we got to turn down the major diameter for the threads. And then we can start to taper, but at least we've got the angle set and now we don't have to worry about that anymore. Somehow I lost some audio. I don't know what happened. I apologize, but all I'm doing is turning this down to the major diameter of those threads anyway and the appropriate length. So it's no big deal. It's a pretty simple operation. I'm going to use this exact same tool, but with fresh I indexed the insert over to a fresh edge. By the way, I forgot to mention this. I was going to mention it before. The big diameter of the taper, the major diameter, is 2 inches. I didn't know that when I turned this down because I hadn't taken the pulley off. I suspected it was around 2 inches based on the size of that thread, which of course I could measure. So this is just below 2 inches now. It'll be perfect. Oh, I need to measure the minor diameter of the taper, obviously. That's what we'll take it down to. Our final dimension as far as where we stop doing this taper is going to be this small side here. So I'll go measure that, write it down, and we'll just start whittling this away with the compound. You see how it's not even? Yeah, there's something happened when I turned this thing. Something got out of whack. But that's not as important as what we're doing now. So as long as it's in line with the spindle right now, that's all we really care about. Pretty much there, 1.830. So let's just leave it. That'll be good enough. Let's see, I'm going to switch over to threading. And I'm going to go ahead and set for 16 threads per inch. Take a scratch pass, see if we're right. Run a little quick. Let's go down to 270. I was at 360. That looks better. Make sure we're at 16. Yep. Okay. I am not going to use the compound. We are going to go straight in on this one, and hopefully I won't regret that. Because I don't want to change the compound angle here in case we got to do some correcting of this taper or something, which I kind of doubt, but that's my excuse anyway that I'm telling you. Okay, we're getting close. We're just at thread relief depth now, but I kind of guessed at that, so I can't really go off of that. Take a spring pass here. Make sure this thing does not, I don't want to blow these threads, go over. I do not like the chattering, but I know what that's from. Because again, I decided not to do the compound because I thought I might need it again. 29.5 degrees would probably have been better for a thread this size. It's not that fine, not that, it's pretty, you know, deeper than like a 1/4 28. Gee, I hope I got the right pitch. All right, let's keep going. Just starting to crest. Wow. That is nice. There is like no play in there. That's like a machinist thread finish right there. It gets a little bindy up in there, so I'll probably do one more spring pass, because I know where I was set at. Because it is a little tight up in there, and I think we'll be good. There's some rust and crud inside this nut, which doesn't help. I didn't think it was that nasty. But let me tell you what. That is bitchin'. I like it. Oh yeah, I mean, I like the chatter, but who cares? I mean, if I was doing this for somebody, I would have done it differently, but you know, I'm not doing it for anybody but some bonehead. Like I said, I don't like the chattering at the base of the threads, but this thing fits perfect, and that's all right. Guys, if I had been cutting the way I should have been with the 29.5 degree angle, cutting on the front side of the tool instead of plunging, which is typically a no-no with a thread bigger than, you know, a fine thread, then, you know, but I wanted to keep the angle just in case I needed to address this this taper here, because we still haven't tried that, which we're about to do here. Let's go ahead and slip the pulley over and just see how it fits. I'm going to put a piece of wood here like I normally do. I want to protect the ways in case it gets away from me. Oh yeah, that sure seems to fit good. I mean, I could glue it up and everything, but you know, as long as it runs pretty straight. Normally you'd put some Prussian blue or something on it, or even some marker, rub it on there, check the high spots, do some fine sanding, things like that. But as I said, I'm not really going to worry about that too much. That's tight enough just to try it. Let's put some center support back on it. Okay. Not too shabby. I don't even have that nut tight really drawing it up on the spline to spline. Jeez, what am I thinking? On that thingy there, the taper too much. You can take that out. Let's get this over here. I just want to see if I can squeeze this guy in here and see how something's running. Showing about a, well, I'll show you here. Whoops. I smacked your heads against that wrench. I apologize. Showing 5/8 thou or so on that particular one. I don't think that that is the bar or the taper, because this is all the same setup that we just used for that. I think that this is just what we're seeing on this pulley when it's actually in use. I think that there's just a problem the way it was machined. This one's running a little better, like 4 thou. So you can see the difference here. That one's at 4 thou, that one was like close to 8. I mean, really, this thing's all over the page, and that's only a couple thou there. So this thing just really needs to be skimmed, and I found that to be the case on the other ones as well. But that'll be in another episode because we're out of time. This video was specifically about the figuring out how to measure, set up, and machine this arbor up to the threads and what we're doing right now. Next one, we'll actually get into cutting this, which probably won't be a very long video, but we're going to be putting it back on after we get done. We'll try it out and see how good it is. Clean this all off real well. I put a little Prussian blue, excuse me, I got gas, inside the bore. Let's see how it transfers over to the taper and see how good the taper is. That feels real tight. You like bitching. Well, we got a couple of spots there. It's really hitting mainly on one side, looks like. No, that actually is okay, because I thought maybe I didn't have good contact, but no, that's all right. Here, let me show you. Must have just been the way I had it pushed up there. So there's the Prussian blue transfer over to the taper. It's a little bit weak here. It's a little light right there, heavier there, and again light over there. But we're getting good contact up in there, and it's enough to keep the thing lined up. So I'm confident that, you know, because we haven't changed the setup, I'm confident that this is in line with that. Because we bumped that over with a little shim, 5 thou aluminum shim from a pop can. Got this, we're running within 2 or so, well, 2 to 3. And then got the taper cut in that setup. I'm not taking this out. I'm gonna leave this in. And then when I get back to this, I'm going to do it in the exact same setup. That way we don't change nothing. We'll have the most accuracy. But yeah, I'm pretty happy about that.